Hey, Amy.
Hi, Mike.
All right, so I only just saw your chat message there about Mark's uh microphone.
Yeah.
We'll bring him in and we'll see what we can do about that.
Okay. And just FYI, when I just clicked on the link now,
Yeah.
is for the first time it asked me for the passcode, which was not a problem, but I just wonder if it was that link. Remember I had questioned you about that link? Because there was some the last digit wasn't like underlined like it.
Oh.
So anyway, you might have to say something to people as they try to join that they might have to put the rocks in.
Okay. Well,
I never did that before, so
I'm sure that they're just improving their security measures.
Well, I didn't have to do it for the virtual happy hour, so I don't know.
I might have also disabled something. So all right, I'm gonna let Mark in.
Just making you aware of it.
No, I appreciate that. We'll see. Hey, Mark. Can you hear?
Something's wrong with it, but sort of.
What are you having a problem hearing me or
Well, that's better. It's not. I can't hear you consistently, I think.
Well, we were having some problems hearing you consistently in the happy hour.
Yeah, I had no problem there.
Okay. Well, now I hear you just fine. So I'd much rather we hear you fine than people hear you fine.
Sure.
Do you want to do a quick practice on like sharing your screen and stuff?
Well, that's fine. That's fine. I can do that. Hang on a minute. Let me pull that thing up. And, hang on a minute.
That's okay.
From the beginning. Back to Zoom. Screen share. Host disabled participant screen sharing. I cannot share.
I always forget that. Give me a second. Okay, now give it a shot.
All right. How are we doing there?
I see your screen.
Good deal.
Now I see your PowerPoint. So wonderful. We're good.
Okay. Okay, I'll park it for now then.
Wonderful. Okay. So how we normally do this then is we kind of, since we still have about 25 minutes to start, I usually mute everyone's video and audio, and I put up a little something on the screen for folk to put in their PG numbers and such. And then we'll actually get started at 6:30 then. So you basically have some time to hang out. And that's just a time to get in and for us to practice, because if something had gone awry, it's good.
Yeah, no, it's all right. I had given this to National Groundwater Association back in the fall. It's pretty much the same thing. It was well received by that Zoom audience, so here we are.
Yeah. Well, I'm looking forward to it. I know everyone's looking forward to.
Yeah. We have cheap clients. We try to do cheap things cheaply, and using low-hanging fruit in the form of free data published by the USGS. Well, there's nothing cheaper than that. So that's what this is about. But that's that. But we seem good to go here, Zoom wise. And I miss being able to do it in person. Have you guys given any thought
We
to
are
what
working on that right now.
Yeah.
We'll probably be getting back in to things come the beginning of our next session. But we're kind of finalizing where we can go. We've had some location changes, so we're not going to be at our normal spot that we have been. But it should all still be good, our options.
Okay.
It's all more information coming.
Very well.
All right, well, I'm going to mute everyone's stuff, and then I'm going to get things going. So just hang back until we kind of call on everybody. Hello, everyone. I just wanted to kind of hop in from the ether here and reiterate the image we have showing here. So make sure again that everything is muted. And if you want to get your hour credits, please put your PG number in the chat bar. Make sure that it is to everyone, not to like me or anyone specifically. And then just hit enter. And we'll be getting started in about 10 minutes.
Oh, Jesus Christ.
Hello, everyone. So it is 6:30 and we are going to get things started. This is a fine time to remind everyone that if you haven't already, put your PG number in the chat to please do so. So we are going to get Kent up here in just a second. There he is. I'll also ask our speaker, Mark, to get up on here. And Kent, I'll kind of let you take it away.
Thanks, Mike. Welcome, everybody, and to our meeting here. First orders of business, I want to thank Rosanna for hosting our meeting last month. And also thanks to the officers, Mike and Amy and Bill, again, for their participation to make these meetings work as they did. Sorry we had to postpone last week, but you know, that was a short-term thing, and thanks for tuning in a week late. Also, a couple announcements. If you have any nominations for officers, we'd appreciate that. Next month is the annual voting, I guess you'd call it, on officers for HAGs. We'd appreciate anybody who might want to work with us, step in with us, and so forth. Also, and even more importantly, I think, is speakers. We need speakers. We have one speaker for the fall. We have one, of course, for May. We have one speaker for the fall, but usually we have the speakers all slated. And right now we only have one. If you all have, I'm sure you all have a story to tell, and we'd all like to hear your stories, geologically or otherwise. Those of you who have attended the virtual happy hour know there's lots of stories that could be told. again, don't necessarily mean they're geologic, but I think a lot of us, that's why we're here, is to hear a good story. Let's see, we're also working on a venue for if we go to in person and in the fall. We're working on that as well. Just so you know, AEG, who was our host for many years, and we really appreciated their ability to let us use their meeting room. They moved to a different office, and so we don't have access to that. We're working on an alternate. I think that covers my announcements. So we'll go to introducing our speaker, Mark Eisner. Mark is a vice president of Barton and Longdice in Maryland. I've known Mark for probably over 30 years. He was part of the Ari Wright group, and he had started his own company called Advanced Water and Land, which got bought up by Barton and Longdice in 2019. Mark's expertise is in hydrogeology, hydrologic investigations, private, public clients in mid-Atlantic, again, Maryland, Delaware, so forth. Water resources, occurrence movement, management of surface and water science. And again, he had been part of the Ari Wright. He was part of our Maryland office and still works in that area. He has a license in Delaware, Pennsylvania, and New Jersey. This will be, I think, his third time to present to HAGs on a situation that relates to groundwater. And at that, I'll turn it over to Mark. Thanks again for being available to tell us a story. And good to see you.
Well, thank you, everyone. And as I watched everybody sign in, maybe it makes me old. I knew a lot of names. I don't know whether that's good or bad, but I really, really did. And it was a thing for sure. Working on my screen share here, glasses always help. Let's see what we got here. Show all. There we go. So you guys should be able to see this now. Okay. So that is pronounced La Judas. For those of you who don't know, B&L, we call ourselves B&L, and I was founder and president of Advanced Land and Water until I got the opportunity to join a larger organization, candidly traded my independence for a retirement plan. And so I am now a regional vice president, still working in Maryland, where I was born and raised, and working on groundwater supply, exploration, development, permitting, management, protection challenges of various dimension. And so this talk was given originally to National Groundwater Association via Zoom last fall, but it seemed appropriate and ready to go. And as Ken says, HAGs need speakers, so here I am. And a little bit about B&L, if you don't know who we are, that word cloud was stolen from our website and pasted into the PowerPoint. And that's the marketing piece. B&L does lots of different things. Our office does hydrogeology mainly because we were till the acquisition. And so this talk is about getting the most out of free groundwater data because we're cheap, and clients are cheap, and budgets are limited, and we try to make the very most out of what we can find. For example, on U.S. Geological Survey websites and downloads and that kind of thing. We stretch theories to the max. Some might argue beyond every now and then. And we say, oh, we can't do that after all. But, you'd be surprised what you can really do with probably what we all learned maybe in the first 2 years of college. At any rate, hopefully many of you are no stranger to the hydrologic cycle. Those yellow numbers are annual rainfall estimates for the mid-Atlantic. Typically around here, it can vary a little bit. And when I first made this slide years ago, there under precip, it said 40. Well, the data don't really bear out 40 anymore of that much. I think it might be a moving target. Warmer atmosphere holds more water vapor. Need I say more? So it's, my slide, I get to put the yellow numbers on there that I want, and it says 44. At any rate, generally, broadly, about half, if not even a little bit more than half, typically goes back up to the sky through evapotranspiration. And the other half is some combination of surface water runoff and groundwater recharge, depending just where you are. When we work on groundwater, it's
probably the question was like, where can we go see a good map? And I don't.
Hello, did I hear a question?
Nope, just a technical issue there. Fixed it.
Okay, very well. We are often focused on trying to estimate, quantify is probably too big a word, the groundwater recharge component of this. And maybe not even in an average year, but maybe in a drought year, because the question, in our work is often, well, how much can we really withdraw sustainably? And can we trust that number? And as I go through the slides here, it becomes a regulatory agency concern as well. And so we go online and try to find free data, because as I say, we're cheap, clients are cheaper, and we try to do what we can. So the your tax dollar at work, the U.S. Geological Survey maintains really a nationwide network of groundwater hydrographs, and if you know how to find them online, and many of us do, not everybody does, but many of us do, we might not find them exactly everywhere we want them and need them. And we might not find long-term groundwater monitoring data sets from an aquifer that is the one we're trying to study in that location, or from a well that's built exactly as we would want it to be, but they are free data, and free is free. So here's an example of the kind of data one can find for free. And the green hydrograph, and again, over a period of close to 20 years, looks like an EKG, for lack of a better term for it. It's got ups and downs, but there is a, within a predictably stable range of water levels. If those units on the y-axis are feet, feet below ground surface, or that kind of thing, the green data set may reflect seasonal variability and or some temporal anthropogenic use, or probably all of that baked together. But it indicates over the long haul probably a system that is in balance. Over the course of time, over 20 years in the graph, groundwater levels are not getting lower and lower and lower and lower. Lower, they're going up and down with seasons or whatever might be going on there, but they're staying in the same range. And then in the same area, you look at the red data set, and that's from a well screened in a different aquifer, in a multi-layer confined aquifer setting like you find on the Atlantic coastal plain. And there are some dampened ups and downs in there, but again, the overall long-term average there is pretty flat. And then we have the difficult to interpret blue. We didn't really know what to make of the blue well. That was real data in the same place. And we pondered what possibly that meant. And we saw what appeared to be, it's kind of like which of these things is not like the other. A long-term, from the beginning of our data set up till sometime maybe in 2010, a general overall decline in water levels over time. We say, wow, that may be the effect of groundwater use exceeding local recharge there. Groundwater levels are responding generally by going down, 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 down. Yeah, it goes up some too. Did it rain? Did it leak from another aquifer? Was the withdrawal rate unsteady? Probably that one. We don't really know. But the overall, if you let your eye average these data, and again, free data are what they are. You don't always know everything you want to know, but you didn't pay for them. They're free. And then we get to middle of 2010, and boom, up we go again. So we say, wow, something changed. What happened? The hypothesis here and it's only that at this hour, is that the groundwater user, the well owner who was triggering that blue potentiometric decline, maybe the business closed, or they got hooked up to public water from elsewhere, or changed their use pattern. Maybe they started to reuse treated effluent, maybe one of those kinds of things, and boom, up comes the aquifer again. And so all of this exemplifies the fact that there can be a wealth of things, and you don't always know all you want to know. You don't always have all of the answers, but a good, careful look at published data sets can start to paint a picture. If you're, new to an area, trying to start out doing a hydrogeological investigation, this is certainly a tool in the toolbox. Well, on the coastal plain of Maryland, and for that matter, the other Atlantic states that share the sub-horizontal stratified aquifers, the coastal plain, Delaware, New Jersey, Virginia, North Carolina, I think they all kind of work the same way. There's a sub-horizontal tipped layer cake of sands and clays that dips slightly southeastward toward the Atlantic Ocean. And each of those different sand layers is an aquifer. It has a name. Each have different names. And each one, by whatever state it happens to be in, is managed. Sometimes well, sometimes maybe in hindsight there might have been a better way. The agencies try, certainly in most of these states here in the East, tried to manage these aquifers, and their tool is to collect and interpret hydrographs like the ones we just looked at. And to say, yes, you industry, you municipality, you farming operation or aquaculture, whatever it happens to be, can make a reasonable use of water that is under your land, as long as your withdrawal effects are not so great that you're going to adversely impact somebody else's land, somebody else's wells, or that you're going to cause prolonged, unnatural, potentiometric decline, defined in detail in different states and different jurisdictions in different ways. But that's the point. These state water resources agencies endeavor to manage these aquifers sustainably. Sustainably means forever. So we thought. And so in Maryland, we're talking about the aquifers that are southeast of the red dotted line, which is more or less parallel to I-95 or maybe the railroad tracks. We have an unconfined aquifer on top, and we have one or more whipped cream and strawberry layers in our cake, which are our target water supply aquifers. And y'all hungry yet? Between the aquifers, there are confining layers. Each aquifer has its own set of transmissivity and storativity data, its own set of permeability, its own hydraulic conductivity, and its own body of data from monitoring wells that go back maybe to the dawn of time hydrogeologically for this work is World War II. I don't know exactly why that is. It just is. There's like hardly any data prior to World War II, but some of the oldest long-term hydrographs you can find in a published record start then. And so what the law says, and it's a Maryland graphic, but the other ones work the same way. And aquifer must remain an aquifer in perpetuity forever. And Maryland, like the other states, endeavors to regulate groundwater use to manage the functionality of the aquifers so that they remain sustainable water resources in perpetuity. And I used to think the agencies around here were doing that effectively. And I went to a National Groundwater Association short course on groundwater resources management. In 2000, I got off the plane in Denver, Colorado, the day after the Bush-Gore election, and the people there marveled over the fact that I was indeed from a blue state. They'd heard of people like us, but had never met one. And I explained that night over beer soap napkins in a hotel bar the night before the class was going to get underway, everything you see here, how Maryland manages its water resources sustainably. And this old crusty guy from Idaho said, BS, you mine your aquifers just like they are coal, but you have so very much water you don't know you're doing it yet. Do the math. And we had a long eerie conversation about that. I believe that he was right looking back. So what defines perpetuity? It's in the regs, but here comes the Maryland Department of the Environment and other agencies to say, we're going to issue these water permits with a 12-year forward looking window. Even SRBC, some of you are familiar with, has a 30-year window that it might look at for some of the permits that it issues. That's still not forever. And so the question comes, how do you know what does or doesn't happen in perpetuity if that's what the law says? Well, Maryland says, don't worry about it, and here's why. And if you have on this slide, the yellow line is a pre-pumping potentiometric water level for this confined aquifer well that is the oldest water level data documented in the public records, say World War II. And over the course of time, The current water level shown by the teal colored line is lower often. Why? I would argue because the sum total of groundwater use from World War II till now has exceeded natural resource. Translation, it's unsustainable if your standard is perpetuity. But the state holds that with your top of the aquifer way down there where the dark gray meets the light gray, 1,000 feet down, 800 feet down, depending where you are, and as long as you do not cause drawdown to get past that red line, which is 80% of the original drawdown available, that we can manage this. Nothing else matters. And that's the standard for many of these agencies, which means, clients can get their permits, economic growth can happen, construction can occur, and all that's all hunky dory. But if a water utility or whomever has a long-term view, what's going to happen 50 years from now, a century from now, what is now this plentiful groundwater resource may indeed over time come to experience what my colleague in Idaho felt was inevitable, that we're going to run out of water on the coastal plain. So how this works over time is, and this is a map from the Eastern Shore from a permit application submittal report, where one undertakes a simple analytical groundwater flow model, nothing fancy schmancy like mod flow. Remember, all this stuff is done on the cheap. Looks at how much drawdown when at the end of the permit period, 12 years, under some really idealized assumptions about aquifer behavior, Tice assumptions, that kind of thing, homogeneous, isotropic, infinite horizontal extent, bump, bump, bump. And then how much drawdown will we cause to occur halfway to a 1 foot drawdown contour, or in the well of the nearest competing user, that kind of stuff. And so this evidences a gradual evolution in some more sophisticated thought process. And we recognize that in this aquifer and that black north-south line in the middle of the screen is a state boundary between Maryland and Delaware, and this town, which is at the intersection of those two cross sections you see, had wells in the same aquifer as Dover, Delaware. And so there would be, at least in an analytical modeling environment, an interference boundary that would develop where groundwater southwest of the red dotted line would tend to flow toward our wells, and groundwater northeast of the red dotted line would flow toward Dover, Delaware. In truth, there are lots of competing users, and they all have different rates of withdrawals, and an analytical model is not all that sciencey. It's not all that defensible. It's not all that anything, but it's cheap and it's better than nothing. And so this was this is the present standard state of the practice. So it comes to pass, as one grows concerned about all this working in this regulatory scheme, thinking about the word perpetuity, and you say, well, how does perpetuity dovetail with the fact that if I actually make collect a water quality sample and send it to the lab for tritium analysis to age date the groundwater, that it actually recharge the aquifer not last year or last month or over the last rainfall event, but thousands of years ago. And it is hard to feel that we are doing our jobs to help manage this groundwater resource sustainably in perpetuity when the statutory requirements clearly call for sustainable groundwater resources management. The huge question is begged whether any potentiometric decline can be countenanced. Can any decline occur? And have you still be able to say, well, that's okay, I'm still managing the groundwater resource sustainably in perpetuity because ... whatever it is. And so it's an easy place for all of us in this industry to be. We're going to meet the permit application requirements. We're going to cross the T's and dot the I's and placate the requirements that the state places on our clients. And the growing, gnawing question inevitably sometimes is that good enough? But with the tops of these aquifers way down deep, and we're worrying about way up shallow, it doesn't necessarily have to be a problem today. Well, except if it is. Remember, this was about free data from the U.S. Geological Survey. And so we had a project in just west of the Chesapeake Bay in the southern part of Maryland, near where the bay has confluence with the Potomac River. And we went to find a hydrograph in the aquifer of concern for this particular project we had some number of years ago. And it looked just like this. This is a story from about 2004 or so. That is a hydrograph from a confined aquifer in southern Maryland. And those water levels are going down. There's no two ways about it. And it looks, without taking too close a look, like they're even over time going down progressively more steeply, at least to me. So we took a real hard look at the data. And we said, wow, not only are they going down more steeply over time, but you can fit a pretty nice parabola of all the crazy things you could fit to these data. You could fit a parabola to these data with an R squared of 0.98. It's a wonderful fit to a shockingly scary, if you're managing a groundwater resources, aquifer sustainably, parabolic decline in water levels. What's causing that? That's crazy. So our client had water supply wells in the screened in this aquifer of interest and came to oppose a permit application on behalf of another entity 5-10 miles away who sought to make a greater groundwater withdrawal out of new wells screened in this very same aquifer, and said, you guys are going to make this problem even worse. How can you do that? And this went to public hearing. It ultimately went to court. You're looking at a courtroom graphic, or a piece of a courtroom graphic. And the state made a permit decision at the time of the green line and fit to these same data, not the red parabola, which is the one that I fit to all of the data, but to a subset of the data. They drew a blue line with an R squared of only 0.12. And I wondered how that could be good science. And the answer didn't satisfy me scientifically then or now. Broadly, they said, we as the state regulatory agency can control future use of groundwater from this aquifer. We don't have to yet. So they issued the permit. We were kind of aghast. We didn't understand it. It wasn't sciencey to me. It's still not sciencey to me. Even when I tell it, when it's finally safe, maybe to some 17 years later. And so it seemed craziness. So here's what happened. shocker of shockers, somehow the agency was right. Remember that 2004 permit decision? After that, the whole thing stabilized out. I'd have bet you a lot of steak dinners that would not occur, that parabola would have continued to parabolize, or whatever the verb is of parabola. It would have kept going down, but here it is, leveled out. Scientifically, hydrogeologically, I wanted to know why the F that happened. How is that? How did that occur? How did the state know that that would occur? I was so sure I was right on the losing side of the court case or not. I just thought that I was on top of that thing. Well, okay. So should we take a poll? What do you think happens? These are real data. It really, what does anybody think happened? Door number one, the state managed the groundwater resource after all. Door number two, the historic data are screwy in some way. Door number three, maybe use declined in this aquifer for some unrelated reason. And that turns out to have been the thing. The Aquia aquifer in southern Maryland, as it turns out, has arsenic. And that around the same time came to have a much tighter MCL in drinking water. So all these regional water supply wells, community, industrial here for an naval base, they all came to pump instead from different aquifers. So it turned out, for reasons completely unrelated to just potentiometric decline and hydrogeology and all of that, that everything worked out okay. And the use of that overtaxed aquifer relaxed only because it turned out to have a primary drinking water contaminant for which treatment is expensive. And so I leave with the question of, are we doing our jobs when we help our clients get permits and only look at it that far? Do we have a higher obligation, we as scientists in the field, in my case, for most of my career since 1990, in the private sector, working generally for private sector clients, are we doing our jobs well enough if we just help clients comply with permit application requirements and permits and so forth that are in front of them, and don't think about anything else that hard? Or does a greater duty exist? Societal question may exist on whether those of us who consider ourselves, expert or experience, and I know some of you who are scoffing at the fact that I would call myself expert anything, but be that as it may, the question is, does any practicing geologist or hydrogeologist have the obligation, I feel like Dick Wright here on the ethics thing, to ask ourselves the question whether we have a greater obligation kind of to the aquifer, to think about this more holistically than maybe the regulations in there simple construct require. I don't know the answer to that. I just will ask the question, and that's the closing slide that marketing makes me put in these things. I'm done. Thank you. Questions?
All right, wonderful talk. What we normally do in this situation is to have folk type in their questions, and then what we do is, we'll ask you those questions as they come through. So if people have questions, please post them in the chat box.
That really was a lawsuit, and we really lost. And you'd have thought that the data were on our side and we won, but I don't know.
Yeah, that is very interesting. So Nathan asks, so over all the years of using the free data, what is your feeling on its trustworthiness?
I believe that on balance, it's trustworthy in terms of the fact is I don't feel it's falsified. I don't feel, I've never known that it was collected sloppily. I kind of wonder things, and I try to get into it if I can, about frequency of measurement that, if you have a well in the area that's coming on and off every day, and the well is only checked occasionally, quarterly, semi-annually, monthly, whatever it happens to be, manually, you might catch it during a drawdown cycle, during a recovery cycle. There can be trends in there that you can't readily interpret. Some really old wells might be open to more than one aquifer. I try to learn as much about well construction as possibly can. Lauren asks the question about pre-pumping water levels, and this really is just about old historic publications. It's going back to groundwater basic data reports, old well completion reports, geologic drilling logs, that kind of thing. Just find the oldest static water level you possibly can. Sometimes that effort's already been undertaken by others, and in most places it winds up being the 1940s or maybe early 50s, but it's doable. And God, I know all these names. It's like a deja vu for me. Greg asks a minute ago, as this is just screaming on by, how widespread are the big potentiometric problem areas, kind of in the Chesapeake Bay watershed? Definitely around Kent Island, where the Chesapeake Bay Bridge is. The aquifers been drawn below sea level, such that it's a grave risk of saltwater intrusion. There's a comparable concern around Ocean City, and there are regional drawdown concerns in some of the shallower aquifers in southern Maryland. Wells are expensive, coastal plain wells, because of stainless steel screen and that kind of thing, are really expensive just in terms of a capital cost for somebody to drill. And so regulatory agencies have in some places adopted a multi-aquifer groundwater management strategy where they reserve permits for the shallower and cheaper wells for mom and pops, churches and gas stations and shopping centers and that kind of thing, and make the deeper, make the industrial and municipal users, the ones with deeper pockets, drill to deeper aquifers to try to keep everybody from competing with each other less. They're all going by so quick. So somebody else, Kent, do you see another one I should try to get into? Somebody asked the salt water intrusion question. Certainly for the shallower aquifers that are, in direct contact with the brackish and saltwater estuaries, they are at risk. Also, the deeper aquifers get upconing of naturally briny water from down deep, so it's always a thing. It doesn't come all at once. It's kind of like heart disease. It's the slow killer, but it comes. Anybody else? There were a bunch. It was
By the way, Mark, I hope you don't mind, but you've been doing such a great job of moderating the questions. I'm just going to keep letting you get.
I'm just kind of rolling up here in my little screen, just trying to read these things. I gotta, everybody's PG number. We can play PG bingo, but somebody asked, did we perform our own aquifer testing as part of the case? No, we were latecomers to the party. The work was begun and field work had been performed by another firm. So it was you know, that was part of the thing. And, you know, it was interesting, a really interesting aspect of this related to groundwater recharge out on the coastal plain. I argued that the permit application cannot be supported, that a permit cannot be issued because the rate of withdrawal would exceed the rate of natural recharge and thus would be unsustainable based on very low groundwater recharge rates to the confined aquifers of the Atlantic coastal plain on the order of an inch a year, maybe less. A opposing expert geologist, a guy I know and respect, no slouch by any measure, said, well, I ran a mud flow model of all of this, and I have water balance, imbalance, no problem. And I said, but look at the KVs, the vertical hydraulic conductivities for the clay layers between the aquifers. They're teeny tiny, and that's the limiting factor here. And he said, but I have these big recharge areas from the bay, from the Potomac River, and I said, you can't get that water because the limiting factor is KV. And what we learned in that back and forth, dumbed down for attorneys and juries and a judge. The judge, to his credit, had a bachelor's degree in meteorology. So there was that. He had a little bit of technical background. He was a STEM guy from way back, you know, and he tried as well as he could. At any rate, what we learned, and anybody who does mod flow, anybody who does numerical modeling, bear this one in mind: mod flow presumes water balance is in balance. It does not, test to see whether water balance is in balance. Mod flow keeps giving you water, whether or not the field data back it up or not, to make your model work. But after a while, I felt like Bob Dylan in the Hurricane song. Reuben Carter was going down. So were we, as crazy as it was. So that's the story of that. Be careful of mod flow, though. It's a tool in the toolbox. It's not a panacea, and we learned that. Hope that helped answer that.
Did you answer already what you think of USGS stream stats data?
I know, and my personal jury's still out on that. It's a big step forward. I haven't used it that much yet. But I'm kind of intrigued. And I hope that helps. And on a it's cool as anything. I can't stress it enough to see all these names scrolling past me, people who I've touched and who have touched me, once or twice in the past, years ago, decades ago. Here we all are. Imagine that. It's just kind of cool. It's just kind of cool. It's like the Ari Wright diaspora. It really is.
Any other questions? This is everyone's time to get their question in. This has been a great talk for the end of our spring season. So although sorry, this is not the end one. Our next month is that one. But we've had some really great questions here.
And for me, it's like that scene in the Apollo 13 movie as they were coming back to Earth, and the Earth looks large in the window. For me, retirement looks large in the window, larger and larger by the day. I'll be cutting back hours to part-time and stuff like that, and I'm looking forward, but also still for the chance to participate in HAG stuff from time to time. But that's just upcoming for me personally. If you wonder, whether anybody ever gets old, Father Time always wins at the end. He just does.
So I'm gonna bring it over to Kent then, because if we don't have any other questions, I'll let him close things out.
Very well. I'll stop the share.
Thanks, Mark. I think we all were schooled tonight, because again, I think every one of us looked at that graph and said, yeah, they got a problem. That trend was pretty definitive, but who'd have known that there was another factor in play, and that would have had the effect that it did. There's no way to predict that. And I think it's useful to have that smack, because we all look at our data and say, yeah, this is what's going to happen. And that's what we're asked to do by our clients. That's kind of our mission too. Even if our clients weren't paying for it, we'd be looking at data and making projections. And again, we all need to be schooled like that to expand our perception and expand our functionality as scientists, and hate to call it consultants, but you and I have been that through our careers. And so we just do what we can with the data we have. And that data you showed with the parabola was pretty conclusive to me. But appreciate your case history, and again, getting smacked, and the story. And again, we all certainly benefited by that. We can't know it all, certainly. Again, with all the rest of the members of HAGS. You all have a story you probably could tell. In the fall, we have something like 3 openings to fill. We'd all enjoy hearing stories like this or others. I have a few in my quiver, but again, you don't want to hear me more than once or twice every couple of years. But we appreciate your thinking about pitching in here. And again, thanks, Mark, for our education here tonight. You all have a good night.
Thank you, everyone. I'm going to be ending the meeting now.